Hi, my name is Alexander Knapp and this is Introduction to Combinatorial Game Theory. In the previous video, we defined combinatorial games and we illustrated them with a simple example. In this video, we are going to define a framework that allows us to analyze all combinatorial games, and we also illustrate it with an example. In the previous video, while we were analyzing an example, we noticed that some positions are good positions for the current player and some are bad. We call them winning and losing position. Unfortunately, they were not defined that formally, so let's close this gap and define them formally. In order to do this, we need to define a notion of a terminal position, a position that doesn't have any moves for the current player. It's easy to see that if the current player starts in a terminal position, he or she loses. We call losing positions P positions because it means they're saying that the previous player wins. It's also clear that if you have a position such that we can go to a position where the player next to move should lose, then it's a winning position for us. In other words, if there is a move to a P position, then the starting position is an N position. And finally, if all our moves are leading to N positions, it means that we cannot win because whenever we go, the next player to move wins. And it means that we are in a P position. We illustrate this definition with a simple game similar to the game we analyzed in the previous video. Two players have N chips in a pile. On each turn, the current player should remove 1, 3, or 4 chips. And we are interested in the question which positions are P positions. Let's analyze first several positions and see how it works. So we have either 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 chips in our pile. If we have 0, then we are in a terminal position since we don't have enough chips to remove. So it's a P position by this rule. If we have 1, we can remove 1 chip and go to a P position, so it's an N position. If you have 2 chips, the only possible move is to remove one of them. So we are going to go to an N position, so it's a P position. If you have 3 chips, we can remove all 3 of them and go to a 0, which is a P position. So this is an N position. If you have 4, similarly, we can remove all 4 of them, go to a P position, so it's an N position. If you have 5, we can remove 3, go to 2, which is a P position, so it's an N position. From 6, we can remove 4, go to 2, which is a P position, so it's an N position. Okay. From 7, we can go to 6, we can go to 4, or we can go to 3. And all of them are N positions, so this is a P position. Now we may guess that there is a pattern of form P, N, P, N, 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 which is actually true, and it can be proven using induction. But we are not going to do this now because it's exactly the same as we did in the previous video. In this video, we define P positions and N positions, and we use them to analyze a simple game. In the next video, we are going to analyze much more complicated game, but much more famous as well. It's called the game of Nim, and we are going to show that structure of N and P positions is quite interesting in this game. If you have any questions, ask them in the comments. See you later.